Right. During the holidays, the first 4 pounds cost $3.50 per pound. Package weighing 4.5 pounds would be rounded up to 5 pounds. So the idea there is that that's a break point, is that really anything bigger than 4, I guess that's not really spelled out here, but anyway, okay. Oh, they're saying they would internally round it up to that. Okay. So typically you go to the like end point, like what is 3.5 times 4? What about that end point there? And
Right.
that's kind of the first number you've got to figure out here, because that's going to add to that equals 14. So that's gonna add to kind of your starting amount there. So we know that A is out for that reason, and then from there you have to say, okay, well, that does does the amount match up? And it does. Now C is a little bit different. C is times X, but it's only the pounds that are more than 5 that contribute to this. And that's why this X minus 4 is correct. So you're looking for that offset in both cases. So C would be out. And then the only difference between B and D is that 32 there. So what you got to do is figure out, well, how much does it actually cost to ship the first 10 pounds? And we know the first 4 is 14, but the next 6 cost $3 per pound. Okay. So you have to like check to see if you're all kind of synced up on that front. So the next 6 pounds costs $3. That's 18. 14 plus 18 is 32. That's why letter D is correct.
Okay.
And that's kind of how you want to work through it. You want to eliminate some based on those breakpoints. We saw that in
Right.
early homework assignment, as I recall.
Okay. Um, I want to go over 20 next.
Okay, sounds good. All right. Right. So it says the inverse of this function is used to convert degrees Fahrenheit to degrees Celsius. Determine the formula for the inverse function. Okay, so you have to switch C and F in the original, like whatever variables, you just switch them, and then you solve for the one that's kind of like nested inside. So to do that, you subtract 32. You get C minus 32. And that kind of tells you right away that it's letter C here. But we'll keep going on that. So the next thing is to multiply by 5 over 9. So you're multiplying both sides by 5 over 9. So you end up getting, just flipping the sides here, F equals 5 over 9, C minus 32. And then in your class, you have to actually flip the variables back again. So C is equal to 5 over 9, F minus 32. This is really an order of operations problem. You have to know when you're solving to undo in this direction: addition and subtraction before multiplication and division.
Okay. So C.
That problem does look somewhat familiar. I mean,
Yeah, this
for
is
better that's worth.
mainly
I
review.
actually have a final exam, I think, for this class. I'd have to go look one more time. Um, but we can keep going through
Okay.
because they grab from a pool of questions. I mean, there's no guarantee that those questions would be the same exactly that you would get, but
Right. 23.
23. All right. Okay, so it seems like there's a lot of word problems here. Seems like they're doing a lot of long questions.
Right.
All right, aquarium charges $100 for a person to feed the shark. On average, there are 30 customers per day. The aquarium found that for every $20 increase in price, the average number of customers per day would be reduced by 2. How much money per shark feeding did the aquarium charge to maximize daily revenue? So we need a price times a quantity. And in these types of problems, they always give you one that goes up. We don't know which one it is. We can look back at the words, and one that goes down. They're inversely related, okay? So we have to look here. They're increasing the price. So it's $100 normally, but they're doing a $20 times X increase in price. But that means that quantity goes down. Quantity was 30, but it's going down by 2X. So to keep it kind of simple, the variables always attach themselves to the thing that's going up or going down.
Mm-hmm.
Okay. So this is your revenue function.
Yeah.
Okay. Now there's a couple ways to solve this. One is to go right to the graphing calculator to graph it, figure out where that maximum is. Okay. That does not necessarily give you the answer, but it leads you to the answer. Like, you have to be careful here that what they're asking for, they want the price. That's what they're asking for. X is not the price. X, when multiplied by 20, gives you the price when added to 100. The price is all of this right here. So you got to be careful with that. The other option is to FOIL this and then find the vertex using formulas. Do either of those ways sound more appealing than another? Either graphing it or foiling and getting the vertex.
Usually do the foiling.
Okay.
Yeah.
So we got 100 times 30. Looks like 3,000 minus 200x plus 600x minus 40x squared. So our revenue function is minus 40x squared plus 400x plus 3,000.
Right.
Okay, so from here to find the vertex, you're going to use x equals minus b over 2a. That's minus 400 over 2 times negative 40. I believe that will equal 5. So 5 is the x value. We don't need the y value, although in another problem it could ask you for the y value. It could ask you what the maximum revenue is. X is just the number of price increases. Basically, it's 5 price increases. So that means it's 20, 40, 60, 80, 100. Your price, P of X, is 100 plus 20x. It's 100 plus 20 times 5, which is 200. They should charge more than $175.
Okay. 27.
Okay. Polynomials. Okay. All right. For a particular product, it is determined that the cost function, revenue functions are given by C of X equals this and R of X equals this, where X is the number of items sold and produced. Function represents the profit. Okay. Find a function to represent the profit of function X and determine the number of items that should be produced and sold in order to maximize profit. So profit is revenue minus cost. So it's this minus 0.02 x squared plus 30x minus 0.00005 x cubed plus 4x plus 1200. This one cannot be done by formulas. You do have to graph this.
Okay.
Okay, so I've got a TI-83 virtual thing, or I can use Desmos. What would be best to help you with this problem?
TI-83.
TI-83.
Yeah.
All right. Well, I'm getting mine up. You do not have to simplify this before you put in the calculator. You can leave it as is. Calculator doesn't care how you put it in. Make sure, though, parentheses around the cost function.
Right.
Most of the mistakes are made entering this into the calculator. I did that earlier today, doing some personal stuff. I just entered the numbers wrong. I was like, why is the answer wrong? It's because I entered it wrong. So I am not immune doing this. Point, actually, let me go, sorry, I meant to pull that up. All right, I got the calculator up here. 1, 2, 3, go. There it is. So minus 0.02 x squared, x squared plus 30 x minus parentheses point 1, 2, 3, 4 zeros, 5 x cubed plus 4x plus 1200 close parentheses. And there you have it. All right. So normally when you go to graph this, if you just hit graph, it'll graph and you won't see anything. One of the things you should look back on the answer is that it tells you the x values on the in the answer space. It's like less than 200 all the way up to more than 350. So that's a pretty good indicator that our x min and x max should be like 0 to 500 roughly. So
Okay.
I'm actually going to go to the window and make that change first. I'm going to make my x min 0 to 500. And then I have no idea what to expect for a max here. I'm going to scale it 10% of x, but I'm going to go like 0 to, I'm going to pick a pretty big number, bunch of zeros there. One more, might as well go out to, I think that's 1,000,000. Scale, we'll go 100,000. Now I'm ready to graph. And these are all just guesses. I don't know. Let's see. And I got nothing. Okay. So that's bad. So the thing you can do when you get nothing, which means it probably either entered it wrong or I need to like really zoom out. I'm way far away. So you can always do like a zoom and then it's up here at 9, a zoom fit. And it tries to fit it, but it's not going to really give you exactly what you want, but it's going to give you some. And you can see there it is.
Right.
So I know whatever this is, I need to go way more out to the right. Why I should go up a little bit. So I could have done that first. I was trying to kind of get it. So I'm actually shocked here that I need to go out. So I'm going to go out 1,000. Make this 10,000. Sorry, 10,000. Make this 1,000. 0. So I was way too high on the Y. That's why we couldn't see it.
Right.
It's too far low. So I'm going to go 10,000. 0. And then go 1,000. I like going 10% on my scales. Y scale, X scale, 10%. All right, and then graph. Up. So I went too far out, so I'm going to go back, change my window to, I went way too far out. I don't know, 2,000 sounds about right. Okay, that looks better. So now we need to find the max. And to find the max, you go second calc, which is above trace, and you go to max right there. Hit enter. Once you go left bound, so you trace until you're left of the max, I don't know, we'll say roughly there, and then go right bound, roughly there, and then guess the same spot. Now it bothers me that this number is 650, but it's not anywhere in that answer space. So I do kind of want to check that I've graphed this right, which could change everything. Minus 0.02 x squared plus 30x minus. Oh, I didn't put that's where it is. See, I made a classic mistake there. I didn't put a 5 in. That'll change everything. Apologize for that. So when I go back to the graph, well, there it is. So we can do the same thing. Second calc max 4. Wow, I'm way far away. So you just keep clicking until you get there. There is another way to do this, but this is the most intuitive way. Okay, I'm left of it. There it is. I'm right of it. And you always guess in the spot you just were at. And there, that'll give us 303, which is letter D, if you're looking at the answers.
Okay. I don't want to do 34 next.
34. Alrighty, let's go get it. All right, given the exponential function, what is the domain? What is the range? And describe the function as a transformation function. So there, I believe your final is all multiple choice. I don't think you would get something like this, but we
Right.
can certainly do this. The thing that helps is to have a graph of this. And we can graph it by hand if we know a few things. The first is that -7 there is the horizontal asymptote. So there's a horizontal asymptote at y equals -7. And the graph either comes down and hits it, or it comes up and hits it, or maybe it comes the other way or the other way, but it always sort of approaches it. So that's where maybe graphing it could help, or knowing the transformations. So I don't know. How would you do it? Would you just graph this?
Um, I personally do algebraically,
Okay.
but yeah.
So then let's list the transformations. 1, 2, 1, 2, 3, 4. Okay, we already got one of them down 7. So the first one is left 4. So your parent graph looks like this.
Okay.
So it's going to move that left 4, which we'll do in a moment. The 2 here or the negative, they can go in either order. It's a vertical stretch by 2. Okay, that doesn't do anything except change it to like go up faster. It still kind of looks like this. The negative is the reflection over the x-axis. That will cause it to flip. That's going to have it flip down. And then the down 7 has it further flip down. So it looks something like this here. And we're only doing that to figure out the domain and range. That's why I asked if you would normally graph it, because you can kind of shortcut all that if you
Yeah.
don't think you would remember or aren't sure how to do
I
it.
guess I could also do it graph. I mean,
Yes.
how would I do it graphically?
You just graph it and see what it looks like. You have to kind of know that it's got the shape though, roughly.
Okay.
It would, because it's y equals -7, it'll fit in the standard window. You don't have to worry about like,
All right.
getting something that you can't really see. That's probably the most frustrating thing when you graph and you can't see it.
Mm-hmm.
So from here, domain. So the domain of every exponential function is all real numbers. No exceptions to that.
Okay.
The range though is based on how this thing approaches the line here. The range is either -infinity to the horizontal asymptote, or it's the horizontal asymptote to positive infinity. It just depends whether it approaches it from the down here or approaches it from up here. This one is the one on the left here. You can see that the y values just increase until they get to -7. So in this case, the HA would be -7. And that's kind of more what I think you would expect to see. You'd expect to see a problem where it just asked you for the domain and range of it
Mm-hmm.
with all the possible variations on the answer.
Okay. It's a domain and range.
Okay, so that's it for the domain and range. -infinity to infinity, range is -infinity to -7. And then we did the transformations already here.
Right.
I do think they ask you a question on transformations. It may not be this. I mean, it'd be something on transformations.
Okay. Yeah, I think I might need to review transformations because I've heard like there's like the stretch and there's compression.
Yes. Usually
Um,
they do that with a table. They like give you a table and then say, if this table was transformed, what would be one of the new data points?
right. So if it's like inside the parentheses with the X, then that's like left or right.
And horizontal. So if there's like a
Oh,
2 up here or like a 5 up here, that's a horizontal. And then it's always backwards or opposite when it's inside parentheses. So that's why it's left for. And
right.
normally like a 5, you'd think it'd be a horizontal stretch, but it's actually a compress because it's flipped when it's inside.
So, oh, you're dividing the
You divide the
X?
X values by 5, yeah.
Okay. Yeah, that's
But
what I
then
mean.
they'll put a fraction there, and then you might normally think, oh, that's a uh, flattening, but it ends up being the makes
Right.
double. You end up doubling the X value because it's a fraction, 1/2, for example.
Okay.
It's always flip of what you think it is when it's inside.
hmm But I'm like on the left, like the -2, that's you're multiplying.
Yes, the negative on the outside is reflection of the x-axis. The negative on the inside will be reflection over the y-axis, which you don't see very often. You might
And
see with
then,
logarithms.
okay. And then like the 2 is stretching.
Yes, vertical stretch.
So, and then, so you're multiplying the Y value of
Y
2.
value by 2. Yes.
Okay. Got it.
And then one on the outside, dropping the y value by 7 each time.
Okay. All right. I want to do 37 next.
Sure. I know you're not asking, but you may again want to do them that have multiple choice.
Yeah, these are all optional, but I think like, because I have like a study group and like they just want to get the concept down and like that's,
Okay. Good.
yeah.
Right. So Jennifer invested $P, 3.2% interest compounded continuously. How long does it take to double the original investment? So this is a PE to the RT problem. So there's a couple ways to do this. The rate is 0.032. You always divide by 100 to get that. One way is to just go straight with the P, like say, okay, I'm going to do P and then I'm going to double it. Some students don't like that. They're like, I gotta put a number in there, like 100. And then I want to know how long it takes to get to 200. It's your choice. You can do it either way because when you divide both sides by 100, or if you do it the way I was proposing, which is you just leave it as P, when you divide by P, you still get a 2.
hmm
So it doesn't really matter how you do it, but some people really want a number. It's like, how can we do it if we don't have a number? Well, you can. Um, this is the more important part though. How do you undo E? How do you get the variable out of the exponent when there's an E? Do you remember that?
That's natural log, right?
Natural log. So you take the natural log of both sides.
Right.
Natural log of 2. On the right side, you can, what some students do is they just write it at like this with the exponent. The natural log of E, they undo each other. And it just becomes, this just becomes X because the X comes out in front. The natural log of E is 1. It just becomes X. That's why it's just the exponent here, 0.032. Yes, no, maybe.
Mhm.
You've seen that before.
Yeah.
And then
So,
you divide everything by 0.032.
okay.
So T equals natural log of 2 over 0.032.
Yeah. Okay. So sulfur 2.
Um, yeah, and there is no such thing as money being compounded continuously, by the way. That's that's I don't know, it's made up in textbooks. Doesn't happen that way in the real world.
Right.
Um, it could say triple instead of double, and then instead of 2, it's a 3.
hmm
But this one ends up being 21.7 years. It's a really long time for your money to double. It's because the interest rate is so low. You don't want to do that. You need a much higher interest rate than that.
Yeah. Okay.
Just you always get a problem. Like there's always seems to be a problem like 36 on there. Rewriting the log. Just throw that out there.
36. Oh, wait. It's like knowing the rules.
Mhm.
It's BXA. All right. I think I need to touch up on that. So
Okay.
Think.
I think it's really good that you're doing a study group. I would recommend doing that for every class you take. You know, better way to.
Right.
It is a little bit of a commitment sometimes, but you know, there's just you can, you know, you get a group together, you guys can actually get some stuff done. Okay, so it's either going to be going like from exponential to logarithm or logarithm to exponential. I'm going to give you the answer,
Mhm.
and you're going to try to figure out, you know, you got to try and figure out like why is this the answer kind of thing. And I don't mean that in like a bad way. I mean that you got to kind of see where the numbers go. You know, that goes there, and the D goes there, and the 7 goes there.
There.
So you got to know that mapping. You almost want to have like an example that you look at over and over again that you can write down real quick and just map the letters.
Yeah. How I remember is like BXA and then BAX. It's like so base. Let me think here. So when it's like in exponential form, it's like the
Yeah.
base 7, the
Hmm.
exponent at d5, and then
Yep.
yeah.
Yep. However you want to remember it, these arrows go both ways for a reason because you can go back and forth between
Right.
them.
Mhm. Okay. All right. I think I'm pretty solid on that. But
Okay.
I think I need to touch up on like 38, like
Sure.
expanding it like in that way.
All right. So I'm going to do this. I'm not going to snip in the answers. We'll just we'll just you know, you got them in front of you. So I got to write some rules each time. So the main rule here for the first one is that you have an A over a B, and this becomes natural log A minus natural log of B. Natural log x squared y minus natural log 2EY. Okay, and then these are both products now. So natural log of A times B is natural log of A plus natural log of B. So in this one on the left, your x squared y, your A is x squared and your B is y. So you're going to split those apart. Natural log x squared plus natural log y. You really want to treat the second one like it's in parentheses minus natural log 2 minus natural log e to the y, like that.
Okay.
The last property, like these are the 3 that you need to know. There's the quotient becomes a difference, a product becomes a sum, and then there's if you have something to the exponent comes out in front. So I probably have not written this correctly, but wow, that's really bad. Let me restart. Natural log x to the b becomes b natural log of x. So that exponent comes out in front. So this 2 on the x squared is going to come out in front. This y is going to come out in front there. So it's 2 natural log x plus natural log y minus natural log 2 minus y natural log e. And one more for good measure, the natural log of e is 1. So this bottom line further reduces to just everything exactly as is minus y.
All right.
And then you also have the problems where you're going the other direction where they tell you to take, you know, something like this and go back to the original.
Okay. Um, we'll do the next one next, like 39.
Sure. Do you know what grade you need on the final to get the grade you want in the class? Has that been figured out?
Not really. I feel like currently without the final, I have like an 86 point something in the
Okay.
class.
Does that include homework and extra credit and
Yeah, that was everything calculated
okay.
together, pretty sure. And so we're currently in 86, somewhere around that range. And then
Yeah, so probably need an A to move up to an A, and anything else to just remain at
uh,
the
I
B.
think the final's like around 25% of our grade.
Yeah.
So yeah.
All right. Well, let's see you get it done here. So we're solving for X. First thing is to divide by 5 here. So you got 40 minus e x over 2 equals 16. This is something I like to do. I like to move this e so that it's positive. So I'm actually going to move two things. I'm going to subtract 16 from both sides, but then I'm going to add the e to the x over 2. But then I'm also going to switch sides. Hopefully that's okay. I really want the e to the x over 2 on the left to equal 24 on the right.
Mhm.
So, normally it'd be 24 on the left, but I prefer my e's to be on the left. And you kind of start looking ahead. You're like, all right, well, there's 24 in there, but I got a 2. Maybe that affects it. Got to be careful. So again, natural log to undo the e. So we have x over 2 equals natural log of 24. Solve for x, we multiply both sides by 2. 2 natural log of 24 is your answer.
Mhm.
You cannot multiply inside the logarithm. It has to stay kind of in front here.
I see. Oh, because that rule.
Yes.
Yeah, okay.
Math probably should have like a different thing for like when you can't multiply in, different symbol for that besides parentheses.
Maybe. Yeah.
Would have been clearer for students.
All right. Move on to 40.
Okay. All right. The classic. Okay, it's one question, but it's really 3. All right. All right. Solve for x in each equation. So the logarithm rules that we just did, the quotient to the quotient to subtraction, the product to sum, those are in play here. So you got a log of a minus a log of b. This becomes log of a over b, like this. So it's log 3x minus 1 over x plus 1 equals 1. So we're just manipulating the left-hand side. The difference becomes a quotient.
Okay.
Okay, now we have to undo the log. So it's really log base 10, even though it's not written. If it's not written, it's base 10. The way to undo the log is to use that base on both sides of the equation.
Mm-hmm.
And you saw somewhere that when you have 10 to the log base 10 or b to the log base b, where these are the same, you just get what's inside here. It cancels out. So this becomes 3x minus 1 over x plus 1 equals 10. And from here, you're solving an equation that should look somewhat familiar. You should say, okay, I think I know how to solve that. A couple of ways here. You can divide by 1 on the 10, and then you can cross multiply, or you can clear out the fraction. I don't know, does anything sound good here? This is kind of formatted poorly. Let's put it right there. Like, would you diagonally multiply or just multiply by the x plus 1? Or
I usually multiply x plus 1 over like
okay,
that.
let's do that.
It's just cross
X
multiplying
plus
at the end
1.
of the day. Yeah.
So those cancel. So on the left here, it's just 3x minus 1. On the right, it's 10x plus 10. And then subtract 3x, subtract 3x, subtract 10, subtract 10. Minus 11 equals 7x. Divide by 7, divide by 7. And there you go.
Right. Yeah. Okay.
Now you're supposed to actually check that this works. And you're like, what do you mean? I just got the answer. It's like, yeah, you got an answer, but so you got to go back to the original. I'm going to snip that in. And you're checking that the answer is actually in the domain. Like, can you actually use it? It's like, well, what do you mean? Well, like, does it work? Okay, well, 3 times negative 11 over 7 minus 1 ends up being minus 33 over 7 minus 7 over 7, which is minus 40 over 7. This is bad. You cannot take the logarithm of a negative. There is no solution here. No solution. And it's like, well, how can that be? How can it be that I got an answer, but it doesn't work? Well, because you're using these properties to manipulate the logarithms, and the you're changing something about the problem, which may not always work after you make this change.
Mm.
So always check is this sort of the short of it.
Check. Okay. I'll do that.
So do you want us to do the next one, or do you want us to move on to something else?
Let's. Yeah, we'll do the second part.
Okay.
Yeah.
The third one might be a calculator problem.
Mm.
All right, so this one, you got a product over here on the left. So this becomes natural log 7 minus x, 3x plus 5, which equals the natural log of 24x. Because you got ln on both sides, you could undo it with e, but you can also just set the inside parts equal. You can just set the fact that this part inside here equals this part inside here. So you got 7 minus x, 3x plus 5 equal 24x. On the left, you do have to FOIL. Hopefully you remember that. 21x plus 35 minus 3x squared minus 5x equals 24x. Then you combine like terms. So this is 16x here minus 3x squared plus 16x plus 35 equals 24x. So I'm actually gonna move everything to the right because I want that 3x squared to be positive. Or you can say, okay, I'm gonna move this left and negate everything. That's okay too. And that's probably the more common way to do it.
Mm-hmm.
And then so we got well, I kind of take that back here because to factor this is kind of brutal. I'm not even sure if that works out nicely. You could go to a calculator at this point. Let me check and see if this actually does factor. They really don't emphasize factoring in your college algebra. Yeah, this one does factor. Do you want to know how to do this by hand, or do you want to like do something different to answer it,
I think
like
either or.
graphing? Okay.
Yeah.
Um, so let me get rid of the negative because that's kind of one of the things that's bothersome here. There's kind of they teach this as a there's like a diamond method they teach, but when there's only one factor of one of them, meaning the first or the last, you can use a guess and check approach. So
Mm.
it's going to be 5 and 7 are the factors of 35, and you got to get back to 8. So like for example, 5 times 3x is 15x minus 7x gets you back to 8x. Now I have the experience of doing this a million times. And if you don't like that, you can always graph and you'll find that one of them is -5 and the other is 7/3. You also could get to a place here where you have the answers and you can check that way. Like you're not stuck if you can't factor this. But having said all that, you again need to check your answers because even though they're answers to this problem, a quadratics don't have the same domain as logarithms. So you have to go back and check, like do your answers actually work? Let's do that now. You're really supposed to check them both. So at first glance, you might think, oh, the -5 is bad. Well, 7 minus -5, that's okay. That's positive 12. It gets problematic here because 3 times -5 is -15, plus 5 is -10. So that
Yeah,
one
that's
is,
negative. Yeah.
yeah, that one is excluded, but it's not excluded because it's negative. But you will see in your answer, you'll see -5 and 7/3 and 7/3. And yeah, just
Right.
be careful that the other one is okay. That one does check out.
Okay. And quickly, I want to try to do number 45.
Okay. Help if I could find it. There it is. Oh, yes. You will see if you haven't already these less than, betweens. If you take any more classes in the math department or even like econ stuff, that you see these types of questions. All right. How long will it take to deposit the double in value in years? Okay, so this time you've got $10,000 starting out. And it's 1 plus the interest rate. So we're using P1 plus R over N to the N times T power. That's the formula here. Because it's not compounded continuously, quarterly means that N equals 4. So it's 0.055 divided by 4 to the 4 times T power. And we want to know how long this is going to take to double. Okay. These are the hardest to solve because T is up in the exponent. It's really hard to get that out. You can do it. I would just say, if you guessed some answers, I'll just point that out here, like 10.5, 11.5, 12.5, you probably will get it. Like you don't have to like sit here and struggle, but I'll show you how to work this out. Just keep that in mind. You might get close enough there. So 2 equals 1 plus 0.0554 to the 4t. So from here, you have to use natural log. So you have to take natural log of both sides, natural log of 2 equals. Now that 4t is going to come out in front. And then you divide both sides by the 4 and the natural log of all this stuff over here. So it ends up being t equals the natural log of 2 over 4 natural log 1 plus 0.055 over 4. So if you're going to do this in your TI-83, make sure you put that extra center parentheses around the bottom. That way, you get the calculation right. Very easy to do something wrong. Okay, let's do that here real quick. All right, log of 2 over 4 times log. All right, so I got 12.7. And that was kind of my point, I guess, is if you did 12.5, you'd probably get pretty close to that. So you just sort of have to like maybe nudge it to 12.6 or 12.7 until you kind of say, oh yeah, it's right there. Does that always work? No, but it's a reasonable strategy.
Okay. Oh, 12.68 comes C D. There. Yeah. I think that kind of wraps it for this study guide. And just like a quick question. So like, will like the recorded lesson be ready by tomorrow in like the YouTube? If that's
I am so far behind on that.
right.
The game plan is, yes, here's what I'll do. I can always send you the Zoom link.
Okay.
So if you need it, just text me and say like, hey, like I'm gonna try. I mean,
Yeah.
I had every intention of it, but truthfully, I'm behind on everything. I mean, I was behind on groceries this week. Like, you start working all the time and run out of stuff. But yeah, if you ever get to a place where like, hey, I really need it, I'll make sure you have access to it. That's
Um, yeah. Wait, so the Zoom link has the recording?
No, I got it. So the Zoom side of it, Zoom sends me an email and there's always a link to it that I can just send you to access.
Okay. Yeah, that could work, and that'd be great.
Yeah, yeah, of course. Anything else you'd like to cover?
I think for now that'll be it.
All right.
Yeah, I just